Welcome to Rges Algebra 2, Lesson 13B. We're going to be discussing two different ideas. One is complex fractions, and two, how to clear an equation of fractions. In other words, if I have, we all know that working with whole numbers is generally easier for us. And so if you have an equation to solve and it has fractions in it, how do I deal with that? Well, there's a simple way to get you back on more familiar territory, and that would be by multiplying the entire left side and the right side of the equation by the least common denominator. So we're going to use that technique for both types of problems. For complex fractions, even though there is another way to do it, I'm going to stay with the technique of multiplying by the least common denominator, and when you have denominators in an equation, you're going to multiply both sides of the equation by least common denominators, and then things will look very familiar. So let me work through a lot. So even though these are two different ideas, our technique will be reduced to one concept, multiplying by the least common denominator. For my first example, I have a complex fraction. My denominator, I have an x here, and my denominator here is an x, so my least common denominator will be x. So I'm going to take each of these and distribute a multiplier of x. First in that numerator of the complex fraction, and then in the denominator of the complex fraction. So x times x is x squared, x times 1 minus, x times 1 over x, the x's will cancel and I'll get 1. In the denominator of the complex fraction, x times 1 is x plus, and x times 1 over x, the x's will cancel and I'll get 1. Now I know that this is the difference of squares, so I will factor that to x plus 1 times x minus 1 all over x plus 1. And that's viewed as a unit because it's in the denominator, and these two will cancel, and my final answer will be x minus 1. I'm going to do several more of these. For my next problem, I'm going to identify my denominators. And so my least common denominator will be xm. I'm going to multiply. I have an x here in the numerator of the complex fraction, so I need the m as my multiplier. In my denominator of my complex fraction, I have an m, and so I need the x. I would have put those beforehand over here, but I kind of ran out of room, particularly in the numerator here. But we'll view it as though they're in front. Now, using the distributive property, m times m is m squared minus I need to multiply by the entire least common denominator. Don't make that mistake, please. Okay. All right. So let's go back to here. I apologize for that. Okay, so you're multiplying by the least common denominator in both cases. The numerator and the denominator. Now we're distributing then mx through the numerator, and mx times m will be m squared x minus, the x will cancel in my second term, and I'll get 3m squared. In the denominator, I'll multiply this x times my least common denominator, and I'll get x squared m minus, my m's will cancel, and I'll get x squared. Now, I'm not finished yet because you always now want to simplify. So you simplify a fraction by going ahead and factoring and canceling. So let's do that. I can factor this numerator by identifying the common factor, which is always the first step. M squared is a common factor, leaving me with x minus 3. In the denominator, my common factor will be x squared, leaving me with m minus 1. There's nothing that can cancel there, so that's my answer. Let's do another problem. First, I will identify my denominators. X and y here. And in the denominator of the complex fraction, x and y. Okay. So x, y will be the common denominator. So I'm going to multiply the numerator by that. Watch how this works, because the beauty of this is the canceling that will always give you, will always reduce a complex fraction then to a simple fraction. So in the first term of the numerator, the y's will cancel, and I'm going to get x times x plus y. I could do also distribute that in my head, but I don't want to, because I want to be nice and deliberate, and paper is cheap. Go ahead and write it out. Notice in the second term of the numerator, the x's will cancel, so I will get y times x plus y. Denominator, the first term, the y's cancel, I'll get x. And in the second term of the denominator, the x's cancel, and I'll get y. So what do I need to do now? I'll need to distribute this, gather like terms. So I'll get x squared plus xy minus xy minus y squared all over x minus y. Notice my middle terms drop out. I'll get x squared minus y squared all over x minus y. And perhaps you can see this in your head, but this is the difference of squares. This becomes x plus y times x minus y all over x minus y. I'll regard this as parentheses because it's all under the numerator, and before I can cancel, I need to see it as a unit, whether I write those parentheses in or not. The x minus y's will cancel, and my final answer is x plus y. Let's do another. Now recall that to identify a least common denominator, first off, there's my denominator, there's a denominator, and here's a denominator. But I'm going to have to always simplify these. Now, these are x plus y and x minus y, so I really want my x first. So let's do x squared plus y squared, just writing the second term first and the first term second, and then I'm going to take a negative out front, leaving it with x squared minus y squared, because if I distribute back, I'll get negative x squared plus y squared, which is what I want. And now take that negative sign, combine it with that negative sign to give me a plus. Now altogether, what I've done is simplified that denominator to 8y over x squared minus y squared. This can, of course, the denominator now can factor to x plus y and x minus y. And now I'm ready to identify my least common denominator. Take the first one. Take the second one because it's not duplicated in the first one. And down to the third one, I already have an x plus y and I already have an x minus y. So this is my least common denominator. So in my first term, I already have the x, I'll multiply, let's just look at it this way. I'll multiply it by x plus y times x minus y. In the first term, the x plus, this is not over, it's a multiply. Okay, I just don't really have the room there. Okay. The x plus y cancels out. and I'll be left with x minus y. In the second term of my numerator, the x minus y's cancel out, and I'll be left with 2 times x plus y. Multiplying the denominator now, which I'm really looking over here, right? Taking into account the factoring. A little messy because of the lack of room here, but hopefully you see what I'm doing. So I'm really looking at x, or 8y over x plus y times x minus y. I'm multiplying by the least common denominator, which of course will go to the numerator. The x plus y will cancel. The x minus y will cancel, and I'll be left with that. So put that on pause if you need to, since it got a little bit messy, and make sure that you're convinced that that would be the next step. Now, what I would need to do is distribute and gather like terms. Gathering like terms, I'll have 3x, 2y minus y is plus y, all over 2x. I'm sorry. I don't know what I was looking at. All over 8y. Now, can I cancel out my y's? The answer would be no. I cannot. Let me show that to you. I cannot cancel that and that because of this plus sign. You can only cancel things that are multipliers or factors. Okay. So do not do that. That was all a false idea. Just want to make sure you don't go down that rabbit trail. And your final answer then would be, getting back my red, 3x plus y over 8y. Okay, so that took into account several of the ideas that you have in 3.8 and actually did several of the problems for you, but you do them all on your own before you come back and check these. Now for having an equation with fractions, we're going to do the same kind of idea. We're going to identify our least common denominator. And when we're working with numbers like this, hopefully you've had enough practice that by now you recognize simply that this is going to be 16. Okay. So if I multiply the first term by 16, 4 will go into 16 4 times, and I'll get 3n times 4, or 12n. If I multiply the second term by 16, the 16s will cancel and I'll get 7n. If I multiply the third term by 16, 2 will go into 16 8 times and I'll get minus 8n. If I multiply the fourth term by 16, the 16s will cancel and I'll get 5n. And on the other side of the equation, if I multiply 1/8 by 16, 8 goes into 16 2 times. And look how simple that problem became. So now all I have to do is gather like terms. They're all n terms. I'll get 19n minus 13n, or 6n equals 2, and n equals 3. I'm sorry, I actually made a mistake on the last there. I'm very happy until I get to there, so just being a little careless right there at the end. This will divide both sides by 6 to solve for n, and that will be 2 6, or 1/3. Now, the next problem, all the others, until you get down to 12, are done exactly the same way. So I think that you can follow that. When we get to 12, we have something a little different. These are not fractions written in a fractional form, but they are decimals, which can be converted to a fraction. I'm not going to do that. But notice if I simply multiplied every term, and notice when you're doing this with an equal sign, you must be very, very careful that you are doing it with everything on both sides of the equation. So I'm multiplying every term on both sides of the equation. Okay, so I'm going to multiply by 100. That's going to move my decimal place over to get 70L plus 24 equals 8L plus 920 plus 2L. Now, most people will be more comfortable with that than this. If you want to just leave it like that and solve it, that's okay with me. But they're showing you a technique. So we'll gather up our L's on the left side. Actually, we don't have it only. We'll simplify the right side of the equation. There we go. Speak clearly. 8L plus 2 more L's is 10L plus 920. I'll take my variable to the left side. 70 minus 10 would be 60L. I'll take my number to the right side, minus 24. 10 minus 4 is 6. 1 minus, or 11 minus 2 is 9. 8. Okay. And we'll divide 896 by 60. Goes in one time, leaving me with 296, and goes in 4, let's see. I think I've made a mistake here. Let me look real carefully. Yeah, there's my mistake. It should be minus 2L, so copying it is critical. So let's, that'll change that. Yeah, that'll change quite a bit. All right, let's pull all the way back here. Okay, so my real problem was minus. I actually copied it correctly, but when I get down to this next stage, it should be minus 2L. So I'm going to add it to the other side. I'm going to get 8 minus 2, or 6L, as I combine these like terms, plus 920. Hopefully I haven't made any other mistakes. I'm going to subtract as I move this to the left side. 70 minus 6 is 64L. 920 minus 24. I should have kept that. That'll be 16, 9, 896. And now I'll have to divide by 64. So I'll take 896, divide by 64, go in one time, subtract, and you'll get 256. And now that'll be, there we go. 4 times 4 is 16. 4 times 6 is 24, plus the 1 more is 25. Okay, so L equals 14. I want to show you one more problem, as you'll be doing down below in 16 through 18. So here's my problem, and recall that in order to identify a least common denominator, I first must factor. So let's do that. Next, identify your least common denominator by taking what's in the first denominator after it's factored, times what's in the second denominator after it's factored. I need a 2 from the third one, but I don't need the x minus 5 here to be repeated because I already have it there. So there's my least common denominator. So I'm going to take every term. How many terms do I have? I have 1, 2, 3 on the left side of the equation and 1 on the right side. So you're going to multiply this least common denominator by all 4 terms. Multiplying it by the first term, my x plus 3's will cancel. I'm going to get, or my 2's will cancel. Okay, and I'm going to get x times x minus 5. So put it on pause, make sure you can understand that. For my second term, my x minus 5 will cancel, and I'm going to get 2 times the x already there times the x plus 3. In my third term, nothing will cancel because I don't have a denominator, so I'll have the 3 times the 2. I'll go ahead and do that in my head, and times x plus 3 times x minus 5. And in my last term, I'll have the 2's will cancel, the x minus 5's will cancel, and I'll get 1 times x plus 3. I'm going to leave the rest of this to you. To go ahead and crunch out, you will have to distribute that. You'll first have to do FOIL, and then you'll have to distribute. You'll gather like terms, and you'll solve for x. So do that nice and carefully. Make sure that you can do those next 3 problems. And in addition, you've got 6 word problems at the end. So have a good weekend.